Hello, I'm Sandy Thomas, and my project for the CSC 423 data mining course is using context to determine sarcasm in Reddit comments. So sorry, here we go. So my background is sarcasm detection is an active challenge in NLP and computational pragmatics. Machines can have a hard time detecting sarcasm using traditional text processing techniques because sarcastic language often contradicts the literal language meaning of a phrase or a word or a statement. So my project explores using traditional TF-IDF based machine learning and transformer-based semantic embeddings. And I use a labeled data set of sarcastic and non-sarcastic Reddit comments. And my goal was to determine whether combining TF-IDF with transformer embeddings leads to better sarcasm detection than only using the traditional methods, which is to preface TF-IDF methods. So my problem statement is, how can we accurately classify sarcastic comments using machine learning models, and which feature representation, TF-IDF, the traditional method, or a combination of TF-IDF and transformer embeddings, and which one yields the strongest performance? So my methodology. So number one, I did data preparation, and so I loaded the sarcasm data into a pandas data frame, and I used Google Colab for all of this to take advantage of their cloud computing um, capabilities. And so I did best practice and created a working copy so I don't change the original data set. And then I just cleaned up and did some tokenization, lower casing and stop word removal, and some basic normalization. And then I also downloaded NLTK packages like punched and stop words for pre-processing in the Google Colab environment. And so for feature engineering, sorry, I did the original the TF-IDF vectorization method first, and I converted text into numerical vectors using TF-IDF vectorizer, and then I did some transformer-based embeddings. And then I generated dense semantic embeddings using a modern transformer model. And so I combined the feature set and I concatenated the TF-IDF vectors plus the transform embeddings to create a hybrid representation. And this is what the second one was testing. And so the modeling, I trained multiple classification models. So the foundational TF-IDF model, and then I did an embedding only model and combined a feature model. And so I evaluated each using accuracy, precision, recall, F1 score, confusion matrices, and additional unsupervised analysis. And I ran k-means clustering on sarcastic comments as well, and I expected cluster assignments to explore hidden structure and user sarcasm patterns. And in this picture here, you can see after some of the data cleaning, what some of the comments look like, and just a picture of like what my data set looked like when using like df.head. Some of my results. So my TF-IDF model performance. So here, here's my confusion matrix here. And so the key insight from that was that I had strong performance on non-sarcastic class. So there's a lot of high true negatives, but it struggled more with detecting sarcasm. And when I combined the TF-IDF plus the embeddings model, my confusion matrix here combined is there, and then my metrics. And so I had the best detection of sarcasm among all models when I use the hybrid method. And I'm moving this over here so you can see my performance comparison. So just using the foundational model, I had about a 55% accuracy, but when I did it combined with the foundational model and embedding features, I got up to 63%. Not really the best, but still we can see that, okay, when you start adding different models on top of the foundational model, you can have very great improvements when doing these types of tests with predicting sarcasm. And so, yeah, so with my clustering results, I did k-means to identify distinct subgroups of sarcastic comments, and I indicated sarcasm varies in style and structure and can form meaningful clusters. And so here I wanted to see if there's any relationship between why comments were labeled as sarcastic and so here the cluster one had over 20,000 labels of sarcastic comments. So my future work and my improvements can be some hyperparameter tuning and doing a using a better fine-tuned transformer model. I would also like to explore other transformer models and embedding techniques. And what I'm gonna do most directly now in the future and doing my computational pragmatics work is I want to explore my results and the clustering and really understand why the comments were clustered the way they were and see if there's any, details or anything within those comments that made them be clustered that way and see if I can draw from that to further improve the sarcastic detection model. And yeah, like I said here, just better understand what details the model uses to determine sarcasm. Thank you for listening to my presentation.